Hello everyone, this is Sravanthi, working as Assistant Professor, Department of Chemistry in Institute of Aeronautical Engineering. Today we are going to discuss about definition and terminology of energy sources. So first, what is the fuel? First question is, what is fuel? So fuel is a combustible substance. It containing carbon as a main constituent, which is capable of releasing large amount of heat. So already we know that during burning process, in the presence of oxygen, fuel, it produces heat energy. So burning of fuel, it produces heat energy. So that energy is used for domestic and industrial use purpose. So fuel is a basic combustible substance. It containing main constituent is carbon. So during burning process, fuel burns in the presence of oxygen. It produces heat energy. Is called fuel. What is natural fuel? So fuels which are found in nature. Fuels which are found in nature are called natural fuels. For example, coal, crude petroleum, and natural gas. So which are obtained from nature. That means, for example, fossil fuels, plants and animal materials buried under the earth crust in millions of years. So in the absence, usually absence of air. So in this case, it converts to fossil fuels. So best example of natural fuel is coal, crude petroleum, and natural gas. So which of the fuels which are obtained from nature or found in nature is called natural fuels. What is secondary fuel? So already we know that fuel is a basic combustible substance. During burning process in the presence of oxygen, it produces heat energy. So these fuels are classified into two types, primary fuels and secondary fuels. Now let's discuss what is meaning of secondary fuels. So these fuels which are prepared artificially from the primary fuels are called secondary fuels. So fuels are classified into two types, primary fuels and secondary fuels. So primary fuels means which are obtained from nature, directly obtained from nature. So secondary fuels means which are made artificially from this primary fuels is called secondary fuels. A best example, gasoline, petrol, diesel, heavy oils, etc. These all are the secondary fuels which are obtained from primary fuels. The next question is, what are the units of calorific value? First, what is the meaning of calorific value? How much amount of heat liberated? So, how much amount of heat liberated when a unit mass of fuel is burning? So, that is called calorific value of the fuel. So, here, what are the units of calorific value? So, here, calorie, kilocalorie, British thermal unit, and centigrade heat units. So there are 4 units of calorific value of a fuel: calorie, kilocalorie, British thermal unit, and centigrade heat unit. And next question is, what is meant by gross calorific value, GCV or HCV, high calorific value? So it is the total quantity of heat liberated. Total quantity of heat liberated when a unit mass of fuel. Here unit means, for example, 1 gram or 1 kg or 1 part, etc. So 1 unit mass of fuel is burned completely and the products of combustion have been cooled at room temperature. So it is called gross calorific value. So here you can consider GCV equal how much amount of heat liberated, plus also we consider latent heat of vaporization of water. So here latent heat of vaporization of water means during combustion products also form. These combustion products cooled at room temperature. So the temperature also we consider that. So here it evolved heat is called latent heat. So what is the meaning of gross calorific value? How much amount of heat liberated when a unit mass of fuel is completely burned. And also we can consider combustion products cooled at room temperature is called gross calorific value. Next question is, what is meant by net calorific value? NCV or low calorific value, LCV. So what is meant by net calorific value? So here it is a net heat evolved. Actually, how much amount of heat evolved when a unit mass of fuel is burned. So here we consider only directly how much amount of heat liberated. We cannot consider latent heat of vaporized water or combustion product cooled at low room temperature. So we cannot consider that one. So how much amount of heat liberated when one unit mass of the fuel have been burned completely, and the products are allowed to escape is called net calorific value. So simply we say net calorific value means so how much amount of net heat evolved when a unit mass of fuel is burned completely. So that is called net calorific value or low calorific value of a fuel. So next question is, how many types of fuels are there and what are they? So just now we discussed already, fuel is a combustible substance. What is the meaning of fuel? It is a combustible substance. It containing main constituent is carbon. So during burning process, fuels in the presence of oxygen, it produces heat energy. So that substance is called fuel. So which substance burn in the presence of oxygen completely and produces heat energy is called fuel. So there are generally two types of fuels are there. That is primary fuels and secondary fuels. So based on physical state, these fuels are again subclassified into three types. They are solid fuels, liquid fuels and gaseous fuels. So already we know that solid fuel best example is coal or coke, etc. Liquid fuels, crude petroleum or diesel, kerosene, naphtha, etc. And gaseous fuels such as natural gas, LPG or CNG. So there are two types of fuels are there, that is primary and secondary, but based on physical state, these fuels are again classified into three types, such as solid fuels, liquid fuels and gaseous fuels. And next question is, define coal. So coal is a fossil fuel which occurs in layers of earth crust. So coal is a fossil fuel when we obtain under the earth crust forms, that means plants and animal materials buried in millions of years under the earth crust, then converted into these fossil fuels like coal. And next question is, what are the different varieties of coal formed inside the earth? So here, what are the different varieties of coal formed inside the earth? Peat, lignite, bituminous coal and anthracite coal. So peat, lignite, bituminous coal and anthracite coal. So there are four different types of varieties of coal formed inside, that means under the earth crust. So here peat to anthracite coal, generally usable form of coal is anthracite coal, which is preferred for industrial and domestic usage purpose. So from peat to coal, the percentage of moisture content, volatile matter and ash content increases, and carbon content is increase. Here see, from what are the varieties of coal formed inside the earth? Peat, lignite, bituminous coal and anthracite coal. So here from peat to anthracite coal, the percentage of moisture content, volatile matter and ash content is decreases from peat to anthracite coal, but the percentage of carbon is increases from peat to coal. So most useful form of coal is anthracite coal, most preferred for industrial application purpose and metallurgical application purpose. We prefer coal is anthracite coal. And next question is, what is meant by calorific value? So here it is a total quantity of heat liberated. It is the total quantity of heat liberated when a unit mass of volume of a fuel is burned completely in the presence of sufficient quantity of air or oxygen is called calorific value of fuel. Actually, efficiency of fuel, it can be determined by this taking calorific value. If calorific value increases means that fuel is considered as good fuel. So here calorific value means it is a total quantity of heat liberated when a unit means 1 part, 1 gram or 1 kg. So here total quantity of heat liberated when a unit mass of fuel or volume of the fuel is burned completely in presence of sufficient quantity of air or oxygen. Is called calorific value. And next question is, what is proximate analysis? Generally, this proximate analysis mainly used for to fix the price and quality of coal. To fix the price and quality of coal. So here, in this proximate analysis comprises the mass, percentage of moisture, ash, volatile matter and fixed carbon. So which are obtained from a series of 3 standardized tests. So simply we say proximate analysis mainly used for to fix the price and quality of coal. So here in this purpose we have to determine that the percentage of moisture content, volatile matter, ash content and fixed carbon. How much percentage present in this coal. So in this we can determine the percentage of moisture content, volatile matter and fixed carbon and ash content in this approximate analysis. We should analyze for what purpose? To fix the price and quality of coal. And next question is, how many types of coal analysis are there? So already we know that coal, what purpose we analyze this coal? To fix the price and quality of coal and which type of coal is used for some special particularly metallurgical application purpose. So that purpose we should analyze that coal. So here there are 2 types of analysis of coal there. So one is a proximate analysis and another one is ultimate analysis. So there are 2 types of analysis of coal. One is proximate analysis and another one is ultimate analysis. And next question is, what is ultimate analysis of fuel? So your ultimate analysis for solid fuels include moisture, ash, sulfur, carbon, hydrogen, nitrogen and oxygen by difference. So here simply we say what is ultimate analysis of fuel means which type of coal is suitable for some special industrial or metallurgical application purpose. That purpose we analyze coal by using this ultimate analysis process. So that purpose we should analyze. We have to analyze the percentage of carbon, sulfur, nitrogen, sulfur, ash and fixed carbon. So how much percentage present in this coal? We should analyze that one. So the percentage of carbon and hydrogen, nitrogen, sulfur and ash mainly should analyze in this ultimate analysis process. Next one is, what is the temperature for determination of volatile matter? So here volatile matter is determined at the loss in the mass. So less than due to the moisture when a sample is heated 900 degrees centigrade period of 7 minutes. So that means how can we determine the percentage of volatile matter present in coal sample? So that purpose, what is the process? Already we discussed previous theory classes, proximate analysis class. We already discussed that. So how can we determine the volatile matter present in coal sample? So known after completing moisture content process. So the remaining coal sample taken crucible, heated in muffle furnace, here maintaining temperature ranges 900 degrees centigrade for 7 minutes. So here, if in case the volatile matter percentage present in this coal sample, it can be evaporated. That means reduce the weight, express that the percentage of volatile matter present in coal sample. And next question is, what is ash? What is ash in proximate analysis? So here, ash is one of biological materials. It consisting mainly of salty inorganic constituents. So good coal always containing less percentage of ash, because if in case this percentage increases means it reduces the calorific value of fuel and do not support burning. It formation of clinkers, so do not support the burning. And next question is, what is average composition of petroleum? So the average composition of petroleum is carbon equal 79 to 87 percentage and hydrogen equal 11 to 14.8 percentage, and sulfur is the 0.1 to 3.5 percentage of sulfur, and nitrogen and oxygen is 0.1 to 0.5 percentage. So what is the meaning here? Coal contains or fuel containing main constituent is carbon. If this percentage increases means calorific value of the fuel also increases. So good coal always containing high percentage of carbon. And what is fixed carbon in coal? So fixed carbon is a measure of the amount of non-volatile carbon remaining in a coal sample. So fixed carbon means it's a measure of amount of non-volatile carbon. So how can you calculate this fixed carbon? So it can be calculated, we can subtract the percentage of moisture content and the percentage of volatile matter and percentage of ash content from 100. You can subtract the percentage of moisture content, percentage of volatile matter and percentage of ash content from 100. So in this way you can calculate the fixed carbon percentage present in coal sample. So fixed carbon is a measure of the amount of non-volatile carbon remaining in a coal sample. The next question is, what is ranking of coal? So here coal rank is a measure of the degree of organic metamorphism. It is also called a qualification of a coal. And next question is, which coal has highest ash content? Which coal has highest ash content? So anthracite is the highest ranked coal with the carbon percentage of above is 87 percentage. So here generally what are the conversion present in this coals to coal? Variety of coal means wood, peat, lignite, bituminous coal, and final stage of coal is anthracite coal. So which coal has the highest ash content? So generally wood, peat, it is having high ash content, and anthracite coal is the highest ranked coal with the carbon percentage of above 80%. That means highest ash content means it containing peat. Peat is the highest ash content coal. Less ash content coal is anthracite coal. What is moisture content? So the moisture content is mass lost from a sample under specified conditions after heating coal in oven 104 degrees centigrade to 110 degrees centigrade. So if in case moisture present in coal sample, so how much percentage of moisture present in coal sample, it can be determined by using proximate analysis. So in this case, the coal sample, 1 gram of coal sample taken in crucible, heating in muffle furnace, here maintaining temperature range is 104 to 110 degrees centigrade for 1 hour. So in this case, if in case what we have observed in that loss in weight of coal sample. So that loss in weight of coal sample expressed as the percentage of moisture content present in coal sample. So how can we calculate this moisture content present in coal sample? So here the percentage of moisture content, it's equal weight of crucible after heating by weight of crucible before heating into 100. So by using this formula, we have to calculate the percentage of moisture content present in coal sample. Next question is, what is petroleum? So petroleum is a naturally occurring liquid found beneath the earth surface that can be refined into fuel. So simply we say that petroleum, it is obtained from under the earth crust. So it containing so many impurities and so many various fractions present in that. So all our impurities which are present in this crude petroleum, we can separate it by refining process. So all the impurities we can remove by refining process and separation of various fractions present in this crude petroleum. So petroleum is a natural occurring liquid found under the earth crust. So next question is, what are the fractions of petroleum? So here example of petroleum products, it's including kerosene, home heating oil, diesel fuel and gasoline. Simply with the kerosene, gasoline or petrol, diesel, naphtha, heavy oils. So many fractions present in this crude petroleum. And next question is, what is refining of crude oil? So here refining breaks crude oil down into various components, so which are then selectively reconfigured into new products. So here refining of crude oil means we can remove, generally when we obtain this crude petroleum under the earth crust, it containing mixture of that means emulsion form, and it contains so many impurities, water, sulfur, etc. So many it's present in that crude petroleum when we obtain under the earth crust. So we can remove all the impurities which are present in crude petroleum and separation of various fractions present in this crude petroleum. The process is called refining of crude petroleum. Next, what is Cottrell's process? So here in this process, separation of colloidal water droplets from crude oil by applying high voltage at 2 electrodes. So here Cottrell's process means it is mainly used for removal of water from this crude petroleum. Generally when we obtain petroleum under the earth crust, it is available in the form of emulsion, that means oil and water. So when we pass this crude petroleum through highly charged electrodes, so this tiny water drops forms a big water drop. It is floating over the oil layer. So it can be consequently we can remove. So this process is mainly used for removal of water from this crude petroleum. And next question is, what are the examples of gaseous fuels? So gaseous fuels, best example is natural gas, producer gas, water gas and coal gas. So here next question is, what is LPG? LPG means stands for liquid petroleum gas. So LPG is a mixture of flammable hydrocarbon gases. It is a mixture of flammable hydrocarbon gases. So that's including propane, butane, isobutane, and mixture of the three is called LPG gases. Main constituent is propane and butane. Next one is, what is the composition of LPG, liquid petroleum gas? So here normal components of LPG is propane and butane. How is CNG made? So CNG is produced by compressing natural gas to less than 1% of its volume at standard atmospheric pressure. So here compressed natural gas, it is similar to natural gas but compressed at high pressure, that means 1000 atmosphere pressure, and low temperature minus 160 degrees centigrade, then converted into compressed natural gas. It is stored in cylinders. So natural gas is compressed at high pressure and low temperature, stored in cylinder, is named as compressed natural gas. It is mostly preferred in automobiles and domestic usage purpose. So where is CNG is used? So is compressed natural gas widely used in auto rickshaws, cars and buses. So what are the applications of liquid petroleum gas, LPG? So LPG commonly used as a fuel for barbecues, grills and gas cooktops and ovens and for gas fireplaces and in portable heaters. We prefer this LPG. We are used in that LPG. So what is the main component of CNG, compressed natural gas? So the main component of CNG is methane. So in this composition is present, the methane percentage is 90%. 80 to 90% present in this CNG. So what is solar energy? So solar energy is the light and heat that come from the sun. So that means this energy is harvested from sun. It is the best example of renewable resource. Renewable energy source. So this energy is harvested from sun is called solar energy. Best example is solar water heaters, solar panels, solar rice cookers. So which are uses sunlight heat energy from the sun. So here solar energy, heat energy converted to electricity in these devices. Next question is, what are fossil fuels? So fossil fuels are coal, petroleum and natural gas. Generally the plants and animal materials buried under the earth crust in millions of years, usually absence of air, so then converted to fossil fuels. The best example of fossil fuels are coal, petroleum and natural gas. And next question is, what is hydropower energy? So hydropower, also known as water power, is the use of falling of or fast running water to produce electricity or to power machines. That means, so here water energy convert into electricity. So here hydropower energy, it is also known as water power, is the use of falling or fast run of water to produce electricity or to power machines. Next question is, what are renewable energy sources? So here, in renewable energy sources such as biomass, geothermal resources, sunlight, water, wind, or natural resources. So that can be converted into clean, usable energy such as bioenergy, geothermal energy and hydropower energy. So these renewable means reproduced by nature. Reproduced by nature. So best example is solar energy, wind energy, tidal energy and hydropower energy. So in these energies, all these are converted into electricity. So all these are best example of renewable energy resources. Next, what is wind energy? So wind energy is also known as wind power. So here it is generated by employing a wind turbine. So which is a device that harness the strength of the wind to generate electricity. So in this case, kinetic energy of wind converted into electrical energy through the windmills. So all these windmills are arranged in one place, that is called wind cluster. So here wind energy converted into electricity, generate electricity. It is also best example of renewable energy resource. And next question is, what are alternative energy resources? So alternative energy refers to energy sources other than fossil fuels. Other than fossil fuels such as coal, petroleum and diesel, and it's including all renewable and nuclear energy sources. So alternative energy resources, it is also called a renewable energy resources. It's not including non-renewable energy resources such as coal, petroleum, gas like fossil fuels, which are not reproduced by nature. What are solar cells? Solar cells made of thin vapors of semiconductor materials like silicon and gallium. So it is also renewable energy resources. Best example is solar cells. Here solar cells are made of thin vapors of semiconductor materials like gallium and silicon. So here converted solar energy into electricity, electrical energy. So in this session, we'll learn about definition terminology of energy resources. What are the definitions involved in that? We discussed this session. So I hope understood all. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.